Welcome to this explainer. Think of your Cambridge physics exam exactly like a high-stakes cricket match. You need to meticulously set your field, you have to read the bowler, who in this case is the incredibly strict Cambridge examiner, and most importantly, you need to score your runs, which are those precious, grade-defining marks. Today, we are absolutely mastering one of the most notoriously tricky, trap-filled topics in the entire Cambridge syllabus, electromotive force versus potential difference. Whether you're sitting for subject code 0625, 0651, 0652, 5054, or even the AS level 9702, this right here is your ultimate examiner's playbook. I want you to picture two typical students sitting in the exam hall right now, staring down a classic 6-mark question. Let's call them Alex and Sam. Now, Alex is what we call the overloader. Alex has practically swallowed the physics textbook. They memorize every single raw physics fact, but when it's time to write, they just throw it all onto the page like spaghetti at a wall, with absolutely zero structural analysis. Then there's Sam. Sam is the rusher. The clock is ticking, the tension is high, and Sam completely misses the specific command word requirements, completely ignores the context of the circuit diagram, and leaves so many easy marks just sitting right there on the table. Both of them are looking at this 6-mark question on EMF and PD, and I can tell you right now, both of them are about to fall into a massive grade-dropping trap. Our challenge today is to ensure you do not make their mistakes. We are going to actively analyze their flawed answers, look at the literal red pen marks they'd receive, and entirely transform your exam strategy.
This quote right here is exactly what is at stake. Principal examiner reports reveal a massive, systemic problem that costs thousands of students their top grades every single year. It says, candidates consistently confuse key terminology. When the examiner reads your exam paper, they are actively looking to see if you actually understand the physical difference between these concepts or if you're just wildly guessing. Let's look at our two students. When Alex writes an answer, they confidently scribble down, EMF is the volts of the battery and PD is the volts of the bulb. Boom! The examiner's red pen instantly comes out, 0 marks for depth. Why? Because it's purely superficial. Then we have Sam. Sam writes, well, they are both just energy divided by charge. Okay, Sam gets maybe 1 method mark for knowing the formula, but totally fails to explain the physical direction of the energy transfer. You see, the Cambridge assessment framework isn't just testing your memory. They don't just want a human encyclopedia. The syllabus strictly prioritizes analytical depth over superficial breadth. If you genuinely want those A-star marks, you have to read the examiner like a pro bowler. You have to know exactly what spin they are putting on the question before you even pick up your pen.
Okay, let's dive into this. Here is the systematic playbook we will use to secure top marks today. We have a 5-step agenda. First, we're going to decode the terminology trap. Second, we'll lock down those crystal clear definitions of EMF and PD. Third, we are hitting the core equations. Fourth, we'll implement a step-by-step problem-solving methodology. And finally, we will unlock the principal examiner insights to help you think exactly like a top-tier candidate. To actually execute this out in the wild, we're going to be using the PEAL framework throughout this explanation. That stands for point, evidence, explanation, and link. It is an absolute game changer for structuring your extended physics answers. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, do it right now so you don't miss out on these grade-saving strategies. All right, let's keep moving.
Section 1, the terminology trap. Let's immediately avoid the most common pitfalls by decoding the specific command words Cambridge uses so we can finally move past those generic, fluffy answers and grab those elusive top marks. Pay close attention here because these are the top 3 examiner warnings pulled directly from the principal examiner reports. First, answers are too vague. Examiners desperately want specific physics details. Saying something like EMF is power is not just vague, it's fundamentally incorrect physics. Second, forgetting format and presentation. Presentation follows really strict conventions in Cambridge exams. You need proper headings, correct terminology, appropriate formats, and incredibly clear annotation. If your working out is a messy scribble in the margins, the examiner literally cannot award you method marks. They aren't going to hunt for your right answer. Third, answers lack specific context. If the question gives you a circuit diagram with a thermistor, your definition of PD needs to reference that exact thermistor, not just some generic component. The academic benchmarks require logical, structured reasoning. This is exactly where the PEAL framework comes in. A perfect answer makes a specific point about energy, provides evidence using the formula, explains the transfer direction, and links back to the specific circuit in the diagram. So let's do a quick 30-second challenge in your head right now.
If a question asks to describe PD across a resistor and you just write volts go down, are you using peel? No. You've completely bypassed the framework and fallen right into the vague, formatless trap that our friend Alex falls into. We have to do better.
Section 2. Defining EMF and PD. Clarifying the core concepts. Listen closely. If you do not define your terms perfectly before writing an extended response, the examiner instantly assumes you don't know the underlying physics.
And this right here brilliantly illustrates the exact definitions you need to memorize, understand, and internalize. This is your physics success blueprint. Electromotive force, or EMF, is strictly defined as the electrical work done by a source in moving a unit charge around a complete circuit. Potential difference, or PD, on the other hand, is the work done by a unit charge passing through a specific component. Do you notice the distinct direction of work here? It's absolutely crucial. EMF is all about energy entering the electrical system from the source, like a battery converting chemical energy into electrical energy. It is giving energy to the charge. PD is about energy leaving the electrical system at a component, like a filament bulb converting that electrical energy into light and thermal energy. Think back to how our student Alex initially answered. They just said EMF is the volts of the battery. Okay, let's transform that right now, live using our precise definitions. Instead, we write, EMF is the electrical work done by the battery, which is our source, in moving a unit charge entirely around the circuit. Boom. Imagine a massive green checkmark appearing right next to that sentence. That is the transformation we are looking for. That is how you secure maximum marks and show the examiner you truly understand the flow of energy.
Section 3. The core physics equations. Now we are going to transition into how these physical, real-world definitions translate into the actual mathematics you need to execute on the exam paper. But hold on, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, back to the math.
Time for our first interactive workshop challenge, the data scan. Look at the formulas on screen. You have 60 seconds in an exam to extract the core trend here. What is it? So the crucial point is that both EMF and PD are measured in volts, represented by the capital letter V. Look at the math. E equals W over Q for EMF, and V equals W over Q for PD. They share an identical mathematical relationship. W stands for electrical work done, which is measured in joules, and Q stands for charge, which is measured in coulombs. So 1 volt is exactly equal to 1 joule per coulomb. This shared unit and identical formula is the exact reason why candidates completely confuse them. It's a massive trap. They think, hey, because the math is exactly the same, the physics concept must be exactly the same. It is absolutely not. You must be able to explain to the examiner that while both measure joules of work per coulomb of charge, EMF represents joules given to the charge by the power supply, and PD represents joules transferred away from the charge by the components. If you can articulate that difference, you are golden.
Section 4. Problem-solving methodology. Let's look at exactly how to secure your method marks. Remember, the Cambridge Academic Framework awards points for logical, structured reasoning, not just the final numerical answer at the bottom of the page. Let's walk through this standardized sequence for data interpretation and problem solving. Step 1. Identify key elements. When you see a complex circuit diagram, do a rapid data scan. Where's the source? What are the components? Step 2. Apply relevant principles. If you're looking at a resistor, you apply V equals W over Q. Step 3. Execute analysis with clear working. Step 4. Verify your results. And Step 5. Present properly using Peel. Now for challenge 2. Find the flaw. I want you to listen to this sample paragraph and find the sentence that is literally hemorrhaging marks. Ready? The battery has an EMF of 12 volts, meaning it does 12 joules of work on the circuit. As charge passes through the 6-volt lamp, the EMF drops by 6 volts. Did you catch it? The fundamental flaw there is saying the EMF drops. No way. EMF is a property of the source. The correct, mark-winning terminology is that there is a potential difference of 6 volts across the lamp. So here is challenge 3, speed writing. In your next practice paper, you have 30 seconds to write one perfect Peel paragraph. State the specific point about the component, provide the formula evidence, explain the energy transfer away from the charge, and link it correctly to the lamp. That structured methodology hands the examiner exactly the logical reasoning they are desperately looking for. Section 5, Principal Examiner Insights. We are now moving completely beyond just surviving the exam to absolutely dominating it by adopting the mindset of a top-tier A-star candidate.
Now, what's really fascinating about this slide is the intense emphasis on evaluative thinking. It explicitly states top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying decisions with evidence. What does that actually mean for our final system? It means we follow 3 rules: decode the command word, apply the PO framework, and master your time management matrix. But beyond just following steps, you must identify limitations. For instance, if a really tough paper 6 question asks why a measured PDE across a circuit might be slightly lower than the calculated EMF of the battery, a top candidate doesn't just panic. They question the assumption of an ideal circuit. They consider a different perspective. They realize that the connecting wires themselves or the internal resistance of the battery might be doing work on the charge. That causes energy losses, thermal energy, or heat to the surroundings. They then justify this decision with evidence. This highly descriptive, analytical, and evaluative framework is the exact barrier that separates a B grade from an A star. It's worth seeing the whole system.
As we wrap up this explainer, I want to leave you with this final, provocative question drawn directly from the Principal Examiner Alert. Are you defining your terms before using them in your extended responses? Are you walking into that exam hall knowing exactly how to differentiate EMF from PD, not just as a math formula, but conceptually? Remember, EMF is the work done by the source moving unit charge around the circuit. PD is the work done by the unit charge passing through a component. The math is the same, but the physics is completely different. Apply this playbook, set your field, decode those command words, and you will never lose those easy marks again. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So, here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Finally, drop a comment below with your target grade for physics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with your study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing those past papers and stay entirely focused. You've got this.